The other four base quantities are represented by symbols of their SI units, namely electric current by I, thermodynamic temperature by K, amount of substance by mole, and luminous intensity by CD. The physical quantity expressed in terms of its base quantities is enclosed in square brackets to show that it is an equation among the dimensions of the quantity and not among the magnitudes. Thus we can write the expression for force as force is equal to mLT power minus 2 as shown. Such an expression for a physical quantity in terms of its base quantities is called its dimensional formula. An equation which equates the quantity with its dimensional formula is called a dimensional equation. Of the 7 base quantities in the SI system, we see that only 3, namely mass, length, and time, exist in the dimensional formula for force. Thus, we can say that the dimensions of all the other 4 base quantities in the expression for force are equal to 0. In mechanics, most derived quantities are related to only the 3 base quantities of the 7, namely mass, length, and time. Let us look at another example. Let us find the dimensional formula for pressure, which is equal to force per unit area. Area is the product of length and breadth. Length and breadth represent the base quantity, length. Thus, area can be expressed as length square, and hence its dimensional formula is L power 2. We know that the dimensional formula of force is mLT power minus 2. Now, the dimensional formula of pressure is obtained as shown. Following the same methodology, we find the dimensional formula for the volume of a body. Volume is the product of length, breadth, and height. Height also represents the base quantity, length. Thus, the dimensional formula of volume is L power 3. Similarly, we can find the dimensional formula of mass density, which is the ratio of mass to volume. The dimensional formula for density is mL power minus 3. So far, we have discussed derived physical quantities, namely force, pressure, and density. These quantities have units, namely Newton, Pascal, and kilogram per meter cube, respectively. But there are certain derived physical quantities that do not have units. For example, relative density is the ratio of the density of a substance to the density of water. As it is the ratio of two identical quantities, it does not have any unit. Therefore, the quantity relative density does not have any dimensional formula. Another example is absolute refractive index, mu, of an optical medium, which is the ratio of the speed of light in air or a vacuum to the velocity of light in the given medium. Refractive index is just a number and is significant even though it does not have any unit, because the value of mu of a medium indicates the extent to which a ray of light bends on entering the medium at a given angle of incidence. Refractive index of a given medium is constant and does not have any dimensional formula. You will learn about refractive index in detail later in the course. We also have certain physical constants, each of which has a unit as well as dimensional formula.